Do this tonight. Not tomorrow. Not after the video. Tonight. Go into your bathroom 2 hours before you sleep. Turn the shower to warm. Not hot, not cold, warm. The temperature where you feel no resistance when you step in, where your skin does not flinch, where your muscles release without effort. Stay for 10 minutes. Then get out. Dry off. Do not check your phone. Walk to your bed. Notice what happens to your body in the next 20 minutes. Your eyelids will feel heavier than usual. Not the heavy of exhaustion. Different kind. Clean. Like something is draining out of your skull and being replaced with something quieter. Your hands and feet will feel warmer than the rest of your body. Noticeably, your fingers will feel flushed. Your palms slightly pink. Your breathing will slow without you telling it to. You did not take a sleeping pill. You did not meditate. You did not drink chamomile tea or take magnesium or put on a white noise machine. You stood under warm water for 10 minutes. And your brain is now doing something that most people spend hundreds of dollars on supplements and devices trying to force it to do. It is initiating sleep, not preparing for sleep, not getting drowsy, initiating. The cascade of biological events that leads to unconsciousness has already begun inside your skull, triggered by a shower. The warmth you felt on your skin was not the mechanism. The warmth was the signal, and the signal traveled from the surface of your skin through your peripheral nervous system into a structure deep in your brain the size of an almond that controls every clock in your body. What happened next, what is happening right now in the 20 minutes after you stepped out, is the part nobody explains. Stay with me, because after this you will never think about a shower the same way again. Your body has two temperatures. Most people know one of them, core temperature. The temperature of your internal organs, your brain, your liver, your heart, measured rectally or with an ear thermometer, approximately 37 degrees Celsius, the number your doctor checks when you are sick. The second temperature is peripheral temperature, the temperature of your skin, your hands, your feet, your forearms. This number is lower than core temperature, and it moves in the opposite direction. This is the mechanism the shower activates. To fall asleep, your core body temperature must drop, not slightly, by approximately 1 to 2 degrees Celsius over the course of the evening. This drop is not optional. It is not a side effect of sleep. It is a prerequisite. The brain cannot initiate the cascade of sleep without it. The temperature drop is the trigger. Your body has one primary system for producing that core temperature drop. It moves heat from the inside to the outside, specifically through the blood vessels in your skin. When your body needs to cool the core, it dilates the peripheral blood vessels. The capillaries in your hands, your feet, your face open wider. Blood flows from the warm core out to the cool surface. The skin radiates the heat into the surrounding air. The core temperature falls. This process is called distal vasodilation, and it is why your hands and feet get warm just before you fall asleep. The warmth you feel in your extremities at night is not comfort. It is your body dumping heat, running the cooling system. Now here is what the shower does. When you stand under warm water, the heat from the water penetrates the skin and warms the peripheral blood vessels directly. The capillaries in your hands, your feet, your face dilate in response to the external warmth. The peripheral temperature rises immediately. Your body detects the dilated peripheral vessels. It interprets the signal correctly. Heat is leaving the core through the periphery, and it accelerates the process. When you step out of the shower, the warm water is gone. The air around you is cooler. The dilated peripheral vessels are now radiating heat into the air at an accelerated rate, because the shower forced them open wider and faster than the body's natural evening process does on its own. The result is a rapid drop in core temperature immediately after the shower. Not gradual, not slow, rapid. Researchers at the University of Texas at Austin conducted a systematic review and meta-analysis published in Sleep Medicine Reviews in 2019, analyzing 17 studies on bathing and sleep. The finding was precise. Bathing in water between 40 and 42.5 degrees Celsius, 1 to 2 hours before sleep, for at least 10 minutes, accelerated sleep onset by an average of 10 minutes, and improved sleep quality scores significantly. 10 minutes faster to fall asleep every night from a shower The mechanism is the core temperature drop. The shower forces distal vasodilation. Distal vasodilation accelerates heat loss from the core. The core temperature falls faster than it would through the body's natural evening cooling process alone. The brain detects the temperature drop and it reads it as a signal, sleep time. But the temperature drop is only what triggers the cascade, because what happens inside the brain once the cascade begins is where the real mechanism lives. And it starts in a structure most people have never heard of. Sit just above the point where your optic nerves cross inside your skull, right at the base of the hypothalamus. Two tiny clusters of approximately 20,000 neurons each, one on each side of the midline. This is the suprachiasmatic nucleus, the SCN, the master clock of your body. It is called the master clock because every other clock in your body synchronizes to it. Your liver has a clock. Your kidneys have a clock. Your immune system has a clock. Every organ, every tissue, every cell in your body runs on a roughly 24-hour oscillation, a circadian rhythm, and all of them take their timing signal from the SCN. The SCN receives direct input from the retina through a dedicated neural pathway called the retinohypothalamic tract. Light hits your retina. The signal goes directly to the SCN. The SCN adjusts the master clock based on the light environment. But the SCN does not only respond to light. It responds to temperature. Core body temperature is one of the primary inputs the SCN uses to calibrate the circadian rhythm. As core temperature falls in the evening, the SCN reads that drop as a timing signal. The clock registers. It is evening. Darkness is coming. Prepare the body for sleep. The SCN then sends the sleep signal through the hypothalamus to the pineal gland. The pineal gland, a small endocrine organ sitting in the center of the brain, behind the third ventricle, responds to the SCN signal by producing melatonin. Melatonin is not a sleeping pill. This is one of the most misunderstood facts in sleep biology. Melatonin does not cause sleep. It does not knock you unconscious. It is a timing signal, a biological darkness message. It tells every cell in your body that night has arrived and that the body should begin the processes it only performs in darkness. The melatonin signal from the pineal gland tells the brain stem to reduce alertness, tells the immune system to begin its nighttime repair cycle, tells the growth hormone axis to prepare for the release that happens in deep sleep, tells the body temperature regulation system to continue lowering the core temperature through the night. The shower accelerates this entire cascade by forcing a rapid peripheral vasodilation and accelerating the core. Temperature drop, the warm shower, delivers a stronger and earlier temperature signal to the SCN than the natural evening cooling process produces alone. The SCN reads a faster temperature drop as a stronger darkness signal. The pineal gland receives the signal earlier. Melatonin rises earlier and more steeply. The sleep cascade initiates faster. This is why the shower feels like it pulls sleep toward you. Not because the warmth is relaxing, though it is, but because the core temperature drop after the shower is telling your master clock that night has arrived, and the clock is responding by firing the biological sequence that leads to sleep. The warm water you felt on your skin was communicating with a structure in your brain that controls every clock in your body, and the message it sent was now. In 2013, a neuroscientist at the University of Rochester named Macon Nedergaard published a paper in Science that changed the way the brain research community understood what sleep is actually for. She had discovered the glymphatic system. The glymphatic system is the brain's waste clearance pathway, a network of channels running alongside the blood vessels of the brain called perivascular spaces through which cerebrospinal fluid flows during sleep. As the CSF moves through these channels, it collects metabolic waste products that accumulated in the brain tissue during waking hours. It flushes them out through the perivascular drainage pathways into the cervical lymphatic system, and eventually into the bloodstream where the liver can process them. The waste products the glymphatic system clears include amyloid beta and tau, proteins, the same proteins that accumulate in abnormal amounts in the brains of people with Alzheimer's disease. The glymphatic system operates almost exclusively during sleep. During waking hours, the brain cells, the neurons and glial cells are slightly swollen from activity. The spaces between them are narrow. The Perivascular channels are partially compressed. CSF flow is restricted. During sleep, specifically during deep non-REM sleep, something happens to the brain cells. They shrink by approximately 60% in volume. The space between them expands dramatically. The perivascular channels open. CSF flows through the brain tissue at a rate 10 times higher than during wakefulness. The waste products that built up during the day, the amyloid beta, the tau, the adenosine, the metabolic byproducts of 12 hours of neural activity, are flushed out in the hours of deep sleep. Every night. If you get enough deep sleep, now here is the connection to the shower. Deep non-REM sleep, the stage where glymphatic clearance is most active, is most abundant in the first half of the night. It is also the stage most dependent on core body temperature. The deeper the core temperature drop at sleep onset, the more deep non-REM sleep the brain produces in the first sleep cycles. The shower, by accelerating the core temperature drop, increases the probability and depth of the deep non-REM sleep in the first cycle of the night. More deep sleep in the first cycle means more glymphatic clearance in the first cycle, more amyloid beta flushed, more tau cleared, more metabolic waste removed from the neural tissue. The person who showers at night and falls asleep faster is not just getting 10 more minutes of sleep. They are entering deep sleep faster. They are giving the glymphatic system more time to operate in its most active phase. The brain that is regularly flushed, that regularly reaches deep sleep early in the night and holds it, is a brain that is accumulating less metabolic waste over time, less amyloid beta building on the neural architecture over the years and decades. This is not a claim that a nightly shower prevents Alzheimer's disease. The evidence does not support that specific claim, and I will not make it. What the evidence does support is this: anything that improves sleep onset, speed, and increases early night deep sleep improves glymphatic clearance. The shower improves sleep onset speed through a well-documented physiological mechanism. The connection from improved sleep onset to improved glymphatic function follows from established neuroscience. The inference is biologically sound. The direct clinical evidence connecting nightly showering to long-term glymphatic health has not been measured. The viewer should hold that distinction. What is not in dispute is what is happening tonight in the hours after. You shower in the channels running alongside the blood vessels of your brain. The cerebrospinal fluid is moving. The waste is being collected. The neural tissue is being flushed. The shower did not do that directly, but it started the clock that made it possible. Your body runs on a cortisol curve. Cortisol is a steroid hormone produced by the adrenal glands sitting on top of your kidneys. It is most commonly described as the stress hormone. That description is accurate but incomplete. Cortisol is also the wakefulness hormone, the alertness signal, the metabolic activator. Cortisol peaks in the first hour after waking, a phenomenon called the cortisol awakening response. The spike is sharp. It triggers alertness, activates metabolism, raises blood sugar, sharpens focus. It is the biological mechanism that makes you functional 30 minutes after the alarm. Through the day, cortisol falls, slowly with fluctuations. By evening, it should be at its lowest point. By the time you attempt sleep, cortisol should be near baseline, low enough that the body can shift from sympathetic activation toward the parasympathetic state that sleep requires. In people who struggle with sleep, cortisol does not follow this curve. The evening cortisol remains elevated. The mind races. The body is alert when it should be winding down. The sympathetic nervous system, the fight or flight system, is still running when it should have handed control to the parasympathetic system hours ago. This is the person who lies in bed exhausted but cannot switch off, who is tired but wired, who wakes at 3 a.m. with thoughts arriving without invitation. Warm water on the skin activates the parasympathetic nervous system through the peripheral thermoreceptors in the skin surface. The warmth signals safety to the nervous system, no threat. No reason for the sympathetic system to remain active. The parasympathetic system, the rest and digest system, begins taking over. Heart rate slows, muscle tension releases, the jaw unclenches. The shoulders drop, but the more important effect is happening in the HPA axis, the hypothalamic pituitary adrenal axis, the regulatory system that controls cortisol production. The hypothalamus, which contains the SCN we discussed, also contains corticotropin-releasing hormone neurons. These neurons respond to thermal input from the skin. Warm skin temperature signals the hypothalamus to reduce CRH output. Less CRH means less ACTH from the pituitary. Less ACTH means less cortisol from the adrenal glands. The warm shower is not relaxing in some vague psychological sense. It is directly suppressing the hormonal axis that produces cortisol. The warmth on your skin is communicating with your hypothalamus, and the message is stand down. The day is over. The threat assessment is complete. Lower the hormone. Studies measuring salivary cortisol before and after warm bathing consistently show a reduction in cortisol levels in the post-bath period. The reduction is modest. This is not a pharmaceutical cortisol suppressant, but it is measurable, consistent, and occurs through a documented physiological pathway. The person who showers at night and then lies in bed without racing thoughts is not simply calm because they are clean. They are calm because their cortisol axis received a thermal signal that accelerated the evening hormone decline. The nervous system handed control to the parasympathetic branch 30 minutes earlier than it would have without the shower. That 30 minutes of earlier parasympathetic dominance is 30 minutes of earlier melatonin effectiveness, 30 minutes of earlier core temperature drop, 30 minutes of earlier sleep onset. Compounded across 365 nights, it is not a small difference. There is a fifth mechanism, one that does not appear in the sleep literature because researchers have not studied it directly, but the anatomy supports it. And I want to be transparent that this sits on a different shelf than the temperature and cortisol data. Your skin is your largest sensory organ. It contains approximately 5 million sensory receptors, thermoreceptors that detect temperature, mechanoreceptors that detect pressure and touch, nociceptors that detect pain, C-tactile afferents, a specific class of receptor found in hairy skin that respond to light-stroking touch and project. Directly to the insular cortex, the brain region that processes social bonding, emotional regulation, and interoception, the sense of your own internal state. Throughout the day, these receptors are receiving continuous input. The fabric of your clothes pressing against your skin, the chair beneath you, the keyboard under your fingers, the air on your face, the phone in your hand, every one of those contacts is generating a low-level neural signal. The signals are below conscious awareness. You are not noticing the waistband of your trousers or the collar of your shirt after the first few minutes of wearing them, but the mechanoreceptors are still firing. The signals are still arriving in the somatosensory cortex. The brain is still processing them. The sensory load of a full day of wakefulness includes an enormous volume of subthreshold skin contact signals that the brain is processing continuously without your awareness. The shower changes the sensory input entirely. The water contacts the entire skin surface simultaneously. The thermoreceptors receive a uniform warm signal. The mechanoreceptors receive the gentle pressure of water flow. The C-tactile afferents receive diffuse tactile stimulation across the full body surface. For 10 minutes, the chaotic, fragmented clothing and furniture sensory input of the day is replaced by a single unified warm sensation covering the entire skin. The somatosensory cortex, which has been managing fragmented sensory input for 12 hours, receives a simple, uniform, warm, continuous signal. The processing load drops dramatically. When you step out of the shower, the sensory input changes again. But what you carry into sleep is a somatosensory cortex that has been briefly reset. The accumulated sensory fragmentation of the day has been temporarily replaced by something simpler, warmer, more uniform. Whether this sensory reset contributes meaningfully to sleep quality through a distinct neural mechanism has not been directly measured. The anatomy supports the connection on the C-tactile afferent pathway to the insular cortex, is well documented, and its role in emotional regulation is established, but the direct sleep evidence does not yet exist for this mechanism. The viewer should hold it as a biologically plausible inference, not a confirmed finding. The other four mechanisms stand on their own. The temperature drop is replicated. The SCN cascade is established. The glymphatic connection follows from documented neuroscience. The cortisol suppression is measured. The sensory reset is the hypothesis the anatomy supports and the research has not yet tested. Let me be precise about what the evidence confirms and what it does not. The core temperature drop mechanism is the strongest finding. The University of Texas meta-analysis is direct, replicated, and the physiological mechanism and distal vasodilation accelerating heat loss is textbook thermoregulation. This is not debated. The SCN cascade is established physiology. The temperature input to the circadian clock, the melatonin signal from the pineal gland, the relationship between core temperature drop and sleep onset. This is the foundation of circadian biology. The shower's connection to this cascade follows directly from the temperature mechanism. The cortisol suppression data is consistent across studies measuring salivary cortisol before and after warm bathing. The HPA axis pathway is documented. The effect size is modest but reliable. The glymphatic connection is where the inference begins. That deep sleep drives glymphatic clearance is established. That the shower improves deep sleep onset follows from the temperature mechanism. That improved glymphatic clearance over time has long-term neural benefits is biologically sound. But the chain of inference is 3 steps long, and the direct evidence connecting nightly showering to measurable glymphatic outcomes does not exist. The sensory reset hypothesis sits furthest from confirmed evidence. The anatomy is real. The inference is plausible. The direct measurement has not been done. The viewer should know this. The first 2 mechanisms alone justify the 10 minutes. The third and fourth extend the case substantially. The fifth is where the biology is pointing and where the research has not yet arrived. Go back to that shower you are going to take tonight. You will feel the warm water on your skin. You will feel your shoulders drop. You will feel the jaw release the tension it has been holding since the second meeting of the morning. But now you know what is actually happening. The peripheral blood vessels in your hands and feet are dilating. Heat is moving from your core to your skin surface and radiating into the bathroom. Air. Your core temperature is beginning the drop that your brain has been waiting for since sunset. In the hypothalamus, the suprachiasmatic nucleus is reading the temperature signal. The master clock is registering evening confirmed. It is sending the message to the pineal gland. Melatonin is rising. Not because you are tired, because the clock received the signal and the clock does not question it. In the adrenal glands, the cortisol axis is receiving a thermal instruction to reduce output. The hormone that kept you alert through the afternoon is being suppressed by the warmth on your skin. The sympathetic system is handing control to the parasympathetic system, not because you decided to relax, because the thermoreceptors in your skin told your hypothalamus that the threat assessment is over. And later, in the hours of deep sleep that the temperature drop will help. You reach in the channels running alongside the blood vessels of your brain. Cerebrospinal fluid will be moving, collecting the metabolic waste of the day, flushing the amyloid, clearing the debris of 12 hours of consciousness. All of this from 10 minutes of warm water. Not from a supplement, not from a device, not from a protocol that costs money and requires equipment and produces results that fade the moment you stop buying the product. From water, at the right temperature, at the right time. The sleep industry spent billions developing pills and sprays and wearables and weighted blankets and light therapy devices and white noise machines. All of them trying to do what a warm shower 2 hours before bed does through mechanisms the body already possesses. The core temperature drop, the circadian signal, the cortisol suppression, the glymphatic preparation, the sensory reset. The body already knows how to initiate sleep. It was doing it for 200,000 years before anyone tried to sell you something to help you do it. The shower is not a hack. It is not a biohack. It is not a sleep optimization strategy. It is a thermal signal sent from the surface of your skin to the oldest clock in your brain. And tonight, when you step out of the shower and the cooler air meets your warm skin and you feel that particular heaviness settle behind your eyes, that is not relaxation. That is your brain receiving the signal it was waiting for. Go to sleep.